past is the past. It is done and it cannot change. It cannot move. It cannot be expanding. The Big Bang end of time should be 0, and we should be at plus 13.7 billion years. And beyond us in the future will be 15 billion, plus 20 billion, etc. And yet the teachers of cosmology insist that the universe, which they observe in the past, is expanding. Somehow or other the teachers themselves must have been taught an error. I found out that worldwide there are only about 3,000 professional cosmologists. This means they are a small group. In Australia there are more than twice as many vets. And being a small group, it means that they are all likely to have been taught by the same pool of teachers. The Buddha said, "Do not believe something is so just because a teacher says it is so." I find the first teachers of modern cosmology were a group of just 4, who almost 100 years ago established the basis for all future discussion and all future textbooks. It was immediately obvious that if any one of the 4 had made a mistake, then the whole science would be based upon a faulty foundation. So I looked into the claims of these 4. First, in 1912, an American astronomer called Henrietta Leavitt discovered some special stars called Cepheids. They were special because they shone in such a way that Henrietta proved you could tell how far away these stars were from the Earth. Using Cepheid stars, you could actually measure the distance between the Earth and the star. In 1917, a man called Vesto Slipher, he also worked in America, discovered that the light from most, but not all, nebulae, as galaxies used to be called, had turned red. It was said this proved the nebulae were travelling away from Earth. The reddening of light explained by what is called a Doppler effect. The colour change itself was referred to as a red shift. In 1927, a priest in Belgium called Georges Lemaitre, and then independently in 1929, another very famous American astronomer called Edwin Hubble, he's the man the Space Telescope was named after, both found that the further away a galaxy was, the more red its light had become. They said this proved that the universe was speeding up. In fact, Edwin Hubble, who must have been a very forceful character, because despite coming second, he ended up with most of the credit for the joint discovery, calculated that every time the distance doubles, as measured by Henrietta's stars, so does the speed, as measured by Vesto's redness. This is called the Hubble constant. The lessons taken from these 3 discoveries by the 4 pioneering cosmologists in the 17 years from 1912 to 1929 have been taught ever since, and they are this. The universe is huge, there are billions of galaxies, the galaxies are getting further apart, and they are speeding up, especially when an apparently reluctant Albert Einstein himself could not come up with anything different. In the 1990s, another much larger study showed the same result on a bigger scale, and the theory was said to be proved. If cosmology was a religion, this would be its version of the Moses tablets, its version of the 10 Commandments. But cosmology is a science, and if new facts turn up, it will of course willingly change its position overnight, just to place the science on a firmer foundation. In the realm of physics, there is one law that governs everything. It's called the second law of thermodynamics, and it cannot be broken. Not by 1 gram of matter, or even by the entire universe. The second law of thermodynamics basically says that like a modern clock, everything has to go from a working state with a fully charged battery towards an idle state with a flat battery. The only way a stopped clock can start working again is if the owner replaces or recharges the battery. Another example would be that of a spinning top, which will always fall over. Perpetual, as we all know, the word implies forever and ever, movement would happen if the clock ran forever and the battery was never needed, or if the top just spun forever. But these examples would break the second law, and the second law can't be broken. Perpetual motion is an impossibility. The second law also says that there is an arrow of time. Time must always travel from the past through the present and into the future. Time can never go backwards. That means that for the universe to follow the arrow of time from the past to the present and thence into the future, it must go from Big Bang at 0 time to now at 13.7 billion years. It cannot go from now as 0 time to the Big Bang at minus 13.7 billion years. Stephen Hawking says we cannot time travel into the past simply because it would take too much energy. Why then do cosmologists insist on believing that the past is changing? For that is what the expanding universe theory is doing. It is travelling against the arrow of time, and is getting more and more efficient as it speeds up. It all boils down to that famous red shift that Vesto Slipher discovered. The red shift indicates that the universe is expanding, and every cosmologist worth his or her salt knows it is true. Even Stephen Hawking says in a TEDTalks.com documentary, when we discovered the universe was expanding. Now here I come, an ageing Nosy Parker veterinary physician who is a hobbyist philosopher, has the temerity to ask, is there another explanation? What else could the red shift tell us? Is the red shift a famous fact or an infamous red herring? Could there be another diagnosis? The vet looks in his little textbook, such a simple document by the standards of professional cosmologists who live in a forest of ever-expanding information, and he discovers among the firewood on the forest floor that the red shift really indicates no more than that the distance between the light source and its receptor is increasing. It doesn't matter if the receptor on Earth is stationary and the light source is moving away, or whether the light source is stationary and we, receptors on Earth, are receding from it. Either way, the red shift will be evident. Vesto had a 50-50 chance. He could have opted for the Earth receding from the star, but he opted for the star receding from the Earth. What this discovery does is to infect the foundation stone of cosmology with a concrete cancer, because now there are two possible explanations of a fundamental observation. One will be right, one will be wrong. The new explanation, that the light source is stationary and the Earth is receding, appears to follow the arrow of time. Now the Big Bang is at time 0 and the Earth at time 13.7 billion years, and increasing. The old explanation, the Earth is stationary and the light source is receding, travels against the tide. It places the Earth at time 0 and the Big Bang at 13.7 billion years. That time should be minus 13.7 billion years and would be a maximum. When the minus is inserted, nothing could drive the expansion. Not even 200% dark matter could drive the clock backwards. But just as Stephen Hawking has declared, there just would never be enough energy available to time travel into the past. Why did Vesto opt for receding stars? Perhaps his teacher made a mistake. According to my father's 1957 edition of Chambers' Encyclopedia, Volume 4, page 604, Christian Doppler himself in 1842 had predicted that light from a star receding from an observer should be reddened. He forgot to add that if the observer was receding from the source, there would also be reddening. And when Vesto discovered a redshift 75 years later, it seems he jumped into Christian Doppler's conclusion. But it was the wrong flip of the coin. And Christian may therefore be the teacher who taught the gang of four, who taught everybody else, and everybody forgot that time travels from the past towards the future. So if Vesto Slipher is in error, what happened when Edwin Hubble followed him? What might be wrong in the interpretation of the Hubble constant? Well, in 1929, no one had thought of holograms. But imagine a car starting a trip from Alice Springs and travelling to Adelaide, 1,600 kilometres away. At the start, and then every 100 kilometres, the driver sets up a hologram, a three-dimensional image made of light of his car. When he reaches Adelaide, the driver gets out and presses a button, and in 1 hour all the 16 holograms arrive in Adelaide at the same moment. The nearest hologram will have travelled at 100 kilometres per hour, the next at 200 kilometres per hour, the fourth at 400, the eighth at 800, and the 16th at 1600 kilometres per hour. This is the very same thing that Edwin Hubble observed. It is the Hubble constant. Now the observation is consistent with moving from the past into the future via the present. Double the distance and the speed will appear to double. It does not matter if the holograms are 100, 1,000, 1,000,000, or for that matter 1,000,000,000 kilometres apart. So it seems there is another way of explaining Edwin Hubble's light getting redder and redder. A space full of holograms travelling towards the Earth, which is 13.7 billion light years from the Big Bang. And that gives another two alternative explanations about what has happened to the universe. One, the accepted view that the universe is expanding backwards. The other, a new possibility that nothing of substance is there in the past. No matter, no substance at all, just holograms of light. It's not really a surprising concept. We know that we see a 4-year-old image of Alpha Centauri, and that's the nearest star. What about Henrietta Leavitt's Kephet stars? What else might they tell us? Since 1912, it's been presumed that they indicate the distance between the Earth and the stars. But at these distances, could the real measurement be of time? Time, where in this case 0 is the moment the light was generated, and in the case of the most distant light sources detected so far, let's say it's the Big Bang itself, 13.7 billion years is the time it takes to reach the Earth. While 13.7 billion light years is the distance between Earth and the Big Bang, a single line can be both a ruler measuring distance and a clock measuring time. This is important because time means the interval between events, like how long is it to Christmas, or 2,000 years from Jesus to now. It is always a straight line. Distance, on the other hand, means how far it is between one real place and another, like 1,600 kilometres from Alice Springs to Adelaide, or 4 light years between Alpha Centauri and Earth. Distance can follow contours. It can bounce and be refracted. It does not have to be a straight line. The implication of this proposition is that Henrietta's light is real and the time since it was generated is accurate. But if we talk time instead of distance, the source which generated the light most probably no longer exists. It has moved on, evolving to the next stage of its passage towards being incorporated in the Milky Way or Andromeda or another giant spiral galaxy in the present, leaving an image of light in the time frame where it was. If the matter no longer exists in its apparent form, it cannot be expanding. It should be obvious that every bit of dirt, every bit of matter which was made in the Big Bang is now 13.7 billion years old, and it is probably now all concentrated in the time frame which includes the giant spiral galaxies like the Milky Way and its few cousins, which do not have red light changes. It seems to me that almost without realising it, Stephen Hawking, who was taught by teachers believing in Vesto's redshift rationale, has inadvertently explained how there could be holograms in space. In his television program, Hawking's Universe, Stephen Hawking declares his belief that time travel into the future is possible, if only we could travel at the speed of light. Of course, there is one thing that travels at the speed of light, and that is light itself. That most likely means that light itself might travel into the future. It has the right speed, and importantly, it has very little mass. The next thing Stephen Hawking says is if we want to see time travellers, we in the present should be looking for things from the past. But then cosmologists have been saying for years that space is full of historic images from the past. How can we see the past when there is nothing there? Maybe it's as though we can see the light from a torch after it's been turned off. We see the light, but not the galaxy or the star it comes from. Now remember, I've said a few times that light from any source can only travel from when it is generated or turned on towards the future via the present moment. Light cannot travel into the past. All this means that even though we see the light, the redshift galaxies which made it have evolved. They have merged through gravitation while the light has been travelling towards us. They have eventually become parts of the giant spirals of the Milky Way and Andromeda and the Triangulum galaxies. We cannot see into the future, not even as far as tomorrow, because light has not been generated there yet. If all this is correct, there is no dark matter, it is not needed. Dark energy is another thing altogether. I'm sure that does exist, and because energy has mass, this means I believe in dark mass. But Ben, Nick and I would need to make another film to explain that concept. The universe does not need dark matter to push holograms apart. For a start, they don't weigh anything at all. I think the past, which we observe, is just holograms, and through the Hubble telescope, cosmologists are seeing and photographing amazing, naturally preserved images of a hollow verse, a movie comprising past versions of the real present universe, pictures of what the matter which makes us was doing in previous times. Meanwhile, now in the present, we are told the Milky Way and its sister Andromeda are being drawn together through gravity, just as Sir Isaac Newton would have predicted. Physics is not complicated, it follows rules. Finding the rules is not necessarily easy, but small mistakes in the interpretation of natural law can make the truth very hard to recognise. Max Planck said, "No one will believe me until all the present experts are dead." And Charles Darwin said something similar when he said, "Although I am fully convinced of the truth of the views given in this volume, I by no means expect to convince experienced naturalists whose minds are stocked with a multitude of facts, all viewed during a long course of years from a point of view directly opposite to mine. But I look forward with confidence to the future, to young and rising naturalists who will be able to view both sides of the question with impartiality."